Good morning, friends. So today we will continue with the last session, that is the bit from this unit, that is the pinout diagram. So it comes under the introduction, and after that we will see the various features of this pic. So pic is, as we discussed yesterday, that it is a newer version of the 8051. So it is having a little modification into or the additional features in that 8051, and that is going to be helpful for peripheral interface. So that's why the name is also insisting that it's PIC, that is peripheral interface controller. Yes. So yesterday we have gone through that the first part, that is the introduction, and we have just seen the architecture. So the internal architecture, we have seen that how many blocks are there and what it contains, and in detail of each block we are going to see in the coming session. But before that, we should know that this architecture, that is the internal architecture, how it is been interconnected with the external pins which are available in the DIP format. So this DIP format is having the 40 pin. So from that the PIC family, we are going to study the 16F877A controller. So many controllers are there. So from that one, it is been chosen, and that we have to do the study for that. Okay. So before going to start for that, the as regular, I have chosen some few questions for you. So just be quickly, those who were absent or those who were present, those who have given attention yesterday, so definitely they can write the answer for these questions. So requesting you to just put your answers in the chat box. I'm waiting for 1 or 2 minutes for this 5 questions. So yesterday, if you have noted down, you have drawn the pinout diagram, so definitely you can give the answer for this. Okay, very good. As soon as I've shown this quiz, the answers I'm getting. Very good. So go for the next also. So whenever you are just learning, so that time just no, keep habit of writing the key points or the main points, so that it will be easier in such a quiz and or MCQ questions, or for forever for you. So first question that asks, that is PIC is based on dash dash architecture. So Van Neumann and Harvard. So these two architectures are available in this microcontroller family, and from that the PIC is using the Harvard architecture. So what is the difference between these two? So that is nothing but the separate lines for carrying the data and for carrying the program. So that is program lines and the data lines are different in Harvard. But in that the Van Neumann, so the same bus or the same lines are carrying the data as well as the program code also. So that was the difference. So here it is using the Harvard. The answer I got correct. PIC is using RISC instruction set. True or false? That is asked. So for that also I got the answer, that is it's true. Very good. Then PIC is this dash dash bit microcontroller. So for that no one has attempted. Okay, so that is what the it requires, because we have not discussed how many bit it is microcontroller. But if you have gone through the Google for this pic, so definitely the first sentence will be the that one only. Key, it is a dash dash bit microcontroller. Pin 13 and 14, definitely it is used for the oscillator. So that is also I got the answer. And port A has dash dash pins. So if we have drawn yesterday, that is the pinout diagram. So definitely the answer I received here from Pratik, Ketki, Rupali. That is the 6 pins it is having. So all the answers I received, that is the correct one. So thank you. So with that, we will go once again, just answer slide. So those who are not noted down, so you can note down these answers. That is, it is using Harvard. It is a true 8. It is a 8-bit microcontroller. This particular model, whatever we are going to learn, so that is a 8-bit microcontroller. So in a combination, it can be become a 16-bit and all that, but the basic is it is a known as 8-bit microcontroller. And then that pins are used for oscillator, and port A is having the 6 pins. So let us go to the next. So that is what the yesterday we have gone through the introduction for that, about PIC, and this architecture also we have seen. So once again I am just showing in front of, so that it will be imbibed in the brain. So it is having the 5 ports, IO ports, input output ports, then reset circuit, then program memory and RAM. That was there in 8051 also. This SFR was also there in 8051, but this EEPROM, that was not there. So this is additional in this PIC we can see. Then CPU, that is ALU. So 8051 was having 111 instruction. So for this it is having only the 35 instructions. So that also we will see in the coming session. Then timer. Now there were 2 timers in 8051 if you are remembering, but here 3 timers are there. In addition, interrupts. The in 8051 we have studied the 5 or 6 interrupts. So here total 8 interrupts are there. So that also we will see. Then this WDT, what is this? If you are hearing that, so it will be a watchdog timer. So it's looks a funny one a little, but watchdog timer. So this is the timer one. That is one type of oscillator. It is there, and it is working as a reset circuit. Means to reset the controller. So that is done by this particular watchdog timer. So that is the additional one. Then this CCP module. So this is a new. It was not there in the 8051. So what is this is doing? That this is doing that the comparing, capturing, and PWM. So these 3 operations made this. This is the CCP module. So what is this compare? What is this capture? And what is this PWM? So that also we will see. So as I told yesterday that this PWM, so it is a pulse width modulation. So that signal we will get from this particular uh, controller itself as an output. Then ADC, this was not there inbuilt in the 8051, but we got here that is the inbuilt ADC in this PIC. Then for serial communication, it was there the USART, that was there in 8051, but this is the additional SPI and I2C, that is IIC. So that is the additional serial communication protocols are been added in this PIC, whatever we are going to learn. And then the oscillator, so that was also there, but the frequency was the fixed one, that is a 12 megahertz. But here it is having the not 0 to 20, actually 0 megahertz may not be the frequency, but normally it is been considered as a 20 megahertz frequency for just generation of the clock signal for this controller. So this is what the, and program memory is more, RAM is more. So that way we can compare or we can remember as far as the we have studied the 8051. So next we will have gone through that the pinout diagram, and I asked that the draw the pinout diagram. So I hope all of you has drawn. So if the you have not completed, so just take 1-2 minutes and try to just complete in detail. That is the whatever the nomination it is been given. So if you search on the Google, so these names might be different, it is given on different images. So but the function will be the same one. So accordingly we will follow one this one diagram, and accordingly we will study the function of each of the pin. So 5 ports are there. The ADC, that is analog inputs are there. How many analog inputs are there? Have you observed? So by that time, those who are drawing this pinout diagram, the others can put in the chat box that if you have observed in this diagram, how many analog input pins are there. So you just put in the chat box so that at least one or two students can give this. How many analog input pins are there? So you can also take a close, make a little zoom, and or in the notebook if you are drawn, so you can just put there. Okay, one answer I received, uh, pin 8, 9, 10. That is you have read, madam, AN5, that is analog 5, analog 6 and analog 7. So if analog 5 is there, that means the earlier AN4, AN3, AN2, AN1, AN0 might be there. So take a close look and you will come to know that there are 8 analog inputs. There are 8 analog inputs. Is it so? So just give the confirmation to me if you got the earlier analog inputs, that is AN0 to AN7. Those who were absent yesterday, just take a quick look at this diagram. This is very important. This is the overview what we are going to learn in coming sessions. So this peak is having the 5 ports, uh, port A, port B, port C, port D, and port E. So port C is divided into parts. Port D is divided in 3 parts. Port A and port B are continuous one. They are not divided anywhere. Port E also not divided. It is of only 3 pins. That is RE0, RE1, RE2. The another way this port E can be used as read, write, and CS, that is chip select, or AN5, AN6, and AN7, that is analog pin 5, 6, and 7. So like that, the same pins can be used for different functions. So in that way, one by one, we supposed to just check out the all the this particular pin description. Okay, so let us go to the next point. So let us see this one. So you just keep that the pinout diagram in front of you, that notebook, so that we can compare this particular. So in the pin description, the pin 1. So this is the MCLR. It is active low, so it should be bar on the head. So what is it means? Master clear. So what is its use? That is, this is the first pin used as a master clear pin of this IC. Means if you are remembering in 8051, there is also one reset pin was there, pin number 9. So here, the similarly, pin number 1 is for that reason only. That is a master clear. reset we can remember as. Then pin number 2, if you're written on that diagram, that is RA0 oblique AN0. So RA0, that is register A port and 0 number pin, that is RA0 to RA7. So these 8 pins are there for this port A. Got it? So this is the pin number 2. So the arrows are also very important if you have not drawn, and if you have seen in this diagram arrows. So they are the arrows showing that. Actually here all they have shown in that, so it is a little wrong one, but I will add a different one of the pinout diagram in the coming session, so that the arrows are also very important. That is, whether it is input or whether it is output or whether it is both input output pin. So that is also needed over here. But let us see that the pin number 2, it is the RA0, that is port A 0 pin, or it can be used as analog input 0. So in the both way it can be used. So the description, it has been written, so you just go through it. Port A consists of 6 pins from 2 to 7. All of these are bidirectional IO pin. Pin 2 is the first pin of the port. This pin can also be used as an analog pin AN0, as it is having inbuilt ADC. Okay, so this is what the pin number 2. So in your words, you just note it down, all these points, because this description, no one is having the time to just read that the all description and all that. So in your words, so what is its main function? If I will write port A 0 pin or analog 0 input, that in that wording only, highlighted bullet points only, we're supposed to note it down. No need to just write all the lines and all that. Then pin number 3, that is written RA1 or AN1. So it may be the same one, that is the port A first pin or analog 1 input. So this is pin number 3. Then pin number 4. So it is written here RA2, AN2 and V reference minus. V reference minus, that is the next C. V reference is also the same that of. So what does it mean? A port second pin or analog second pin or negative reference voltage. Negative reference voltage for ADC, it is required for that. So pin number 4 is a special function, that is a negative reference voltage we can give for the ADC. So this is pin number 4. Pin number 5, what is written there? RA3, AN3, V reference plus. That is the similar to above one, that is port A third pin, analog third pin and V reference plus. That is for that the ADC purpose, it is positive reference voltage we can give through this pin. The meaning is that and only one function can be possible at a time, not all the functions for pin 1. So one pin, one function. So that will be the criteria at a time. Then the next one we will go, that is pin number 6. So this pin number 6, what is written there? So RA4 T0CKI, is it? So here only 2 are there. Pin number 6 T0CKI or C1 out. So that is also been added over here, C1 out. So RA4, that is port A 4 pin, timers are there. 3 timers are there: T0, T1, and T2. So from that, T0 CKI, clock input, timer 0, clock input, like that the description for this particular function. And C1 out. C1 out is nothing but inbuilt comparator is also there in this, as we discussed. So for two comparators are there, C1 and C2. So the output of comparator, so that is one of the C1 out, comparator 1 output, pin number 6. So in this way only you can note it down, pin number 6. Similarly, pin number 7. So it is having RA5, AN4, SS bar, and C2 out, and C2 out. So what is this having? So RA5 means port A, 5th pin, then AN4, that is analog 4 pin, and this SS stands for that the synchronous serial port. There is a synchronous serial port, and this pin can be used as a slave select. So SS stands for the slave select. So in this, the master and slave, that concept is going to be used whenever the serial communication as far as concerned. So how to configure this master, how to configure that slave, so that also we will study afterwards. So right now you can just put there, or you can note down that SS is nothing but slave select pin. So this is pin number 7. Then we will move towards the next. So here pin number 8. What is written on that? RE0 oblique RD bar oblique AN5. Means here RE0. So here port E has started. Port E 0 pin, or RD pin, or analog 5 pin, analog input 5 pin. So that is what the description also written, that is port E. It should be the space over here. Port E starts from pin 8 to 10. 3 pins are there for port E, and this is also bidirectional input output port. It can be the analog input 5, or for parallel save port it can be act as a read control pin, which is be active low. That means on the head there should be a bar. So RD bar is a active low pin. So this is what the pin number 8. Similarly, pin number 9, that is RE1 WR bar AN6. Means port E first pin, or it can be used as a write control, or it can be used as a analog input number 6. Analog input number 6. Pin number 9. This is what. Then we will go to the next pin, that is pin number 10. RE2 oblique CS bar oblique A7. Oblique it should be AN7, not only A7, it is AN7. So what is written in that diagram? It is AN7, yes. So it will be AN7. So RE2 means port E third pin, actually 0, 1, 2, like that. So second number pin, but it is a third, counted as a third pin. Or it can be used as a control select, or it can be used as a analog input number 7. That means 8. It is actually, because it starts from the 0. So 0 to 7. So like that up to pin number 10, port A is covered, port E is covered, and analog inputs are covered up to pin number 10. So as we have written there, that is the pin number 11 and 12, that is VCC and ground, as well as they have gone through the two VCCs and two grounds are there. So they have added here on itself, that is pin number 11 and 32 are the VCC, and 12 and 31 are the ground. Okay. So next one, pin number 13 and 14, both the pins are a similar one. So this is oscillator input or the external clock input, clock in, that is external clock input, and here pin number 14, that will work as a clock out. Externally, if you want to give that the you want to give the clock from peak, so this pin can be used as a trigger for external peripheral or the external circuitry. कधी कधी एखाद्या सर्किटला क्लॉकची गरज असते, परंतु मग त्या क्लॉकसाठी सेपरेट सर्किटरी आणण्यापेक्षा किंवा क्रिस्टल ऑसिलेटर लावण्यापेक्षा ह्या पिक मध्ये जो क्लॉक तयार होतोय तर तो तुम्ही बाहेर त्यांना देऊ शकता. दॅट इज ट्रिगर, ट्रिगरिंग द एक्सटर्नल सर्किट. दिस क्लॉक आउट कॅन बी युज्ड. पण जर स्वतःलाच त्याला पिकला एक्सटर्नल ऑसिलेटरची गरज असेल तर तो क्रिस्टल पिन नंबर 13 आणि 14च्या मध्ये लावावा लागतो, की ज्याची फ्रिक्वेन्सी नॉर्मली 10 मेगाहर्ट्ज ते 20 मेगाहर्ट्ज पर्यंत ठेवली जाते. सो दॅट इज व्हॉट इट इज रिटन ओव्हर हिअर, दॅट इज टू प्रोव्हाइड द एक्सटर्नल क्लॉक टू द कंट्रोलर. पिन नंबर 13 and 14. Then pin number 15. What is written there? That is RC0. Then T1 OSO, T1 OSO आणि T1 CKI. Like that it is written. So what it stands for? That is port C has started here. Port C is started over here and त्याची 0th pin म्हणून ही वापरली जाते. So port C consists of 8 pins. It is also bidirectional input output port. Of them, pin 15 is the first, म्हणजे पहिली pin आहे. And it can be used as an oscillator output of timer 2. आता तुम्ही म्हणाल की टायमर 2 म्हणलेलं आहे आणि इथे तर T1 दिसतंय तो आम्हाला. बट इफ यू आर नोईंग दॅट की 3 टायमर आहेत, T0, T1 आणि T2, म्हणून तो सेकंड टायमर झाला T1. So that logic is here. So it is a oscillator output for timer 2 or clock input CKI, म्हणजे clock input for timer 1. एकतर ऑसिलेटर आउटपुट म्हणून वापरला जाऊ शकतो ही पिन, किंवा क्लॉक इनपुट म्हणून वापरला जाऊ शकतो टायमर 1 साठी. दिस पिन नंबर 15. Then pin number 16, RC1 oblique T1 OSI. इथं T1 OSO होतं, here T1 OSI oblique CCP2. So as we discussed that this CCP newly this module is introduced in this, that is capture, compare and PWM. अशी 3 वेगवेगळ्या गोष्टी एकत्र करून एक मॉड्यूल तयार केलेलं आहे. सो दॅट इज व्हॉट CCP. मग त्याला सुद्धा इनपुट लागतात, त्याला सुद्धा क्लॉक लागते, त्याला सुद्धा क्लॉक आउट असते ह्या पूर्ण मॉड्यूलला. मग त्याला कुठली पिन वापरणार तुम्ही, तर दिस इज व्हॉट इट इज गिवन ओव्हर हिअर. सो पिन नंबर 16, इट इज द C port first pin, T1 timer oscillator input, and CCP2 that is capture to input किंवा compare to आउटपुट किंवा PWM टू आउटपुट. तर CCP capture to input or compare to output or PWM to output म्हणून ही पिन वापरली जाते. आता हे PWM आउटपुट काय असतं, कंपेअर आउटपुट काय असतं, कॅप्चर इनपुट काय असतं. सो डेफिनेटली वेन वी विल लर्न इन डिटेल, सो दॅट टाइम यू विल क्लिअर दिस कन्सेप्ट. सो राईट नाव यू जस्ट बी रिमेंबर की यांचे लॉंग फॉर्म काय आहेत आणि याचा कुठं कुठं उपयोग होतो. मग जर एखादा प्रोग्राम आला PWMचा, तर ह्याच्यातल्या कुठल्या कुठल्या पिन, 40 पिन पैकी कुठल्या कुठल्या पिन्स ह्या PWMच्या रिलेटेड आहेत, कुठल्या पिन्स CCPच्या रिलेटेड आहेत. सो ते बायफर्गेशन तुम्ही आत्ताच ह्या आजच्या सेशन नंतर लिहून काढू शकता नोटबुकमध्ये, की जेणेकरून ज्यावेळेस तुम्ही फक्त PWM शिकताल त्यावेळेस तुम्हाला हे रेफरन्सला सोपं पडेल की अरे हां, PWMच्या रिलेटेड एवढ्या पिन्स आहेत की ज्या यू सपोज टू राईट इन द while writing the code for that particular application. Got it? So we will go for the next, that is pin number 17. Pin number 17, it is written that is RC2 oblique CCP1. इथं CCP2 होतं, इथं CCP1 आहे. दोनच मॉड्यूल आहेत ह्याच्यामध्ये. पीक मध्ये दोन मॉड्यूल आहेत, CCP1 आणि CCP2. So pin number 17 can be used as RC2. RC2 म्हणजे काय, तर पोर्ट C पिन नंबर 2 आणि CCP1 that is again the same one, की capture one input or compare one output or PWM one output. So like that CCP1 ला ही पिन वापरू शकतात. तर पिन नंबर 16 आणि 17 या CCP1 आणि CCP2 साठी वापरल्या जातात. So in that way you just note it down somewhere. Then pin number 18. Pin number 18 is what is written RC3, SCK आणि SCL. So these all terminologies, S stands for serial communication. Serial communication च्या रिलेटेड आहेत. सो RC3 म्हणजे काय, तर C पोर्ट 3 नंबरची पिन. And SCK, so that is used for the SPI or the I2C. Actually it is I2C, IIC, integrated circuit, integrated circuit, that is IIC. So sometimes it is written in terms of I2C like this, or I2C. I square वगैरे म्हणण्यापेक्षा I2C, तर IIC it is actually integrated circuit. लक्षात ठेवा, or you just note it down. So this is what it can be used for the SPI output or the input output for synchronous serial clock. तर ज्यावेळेस आपण ऍक्च्युली कोडिंग बघू त्यावेळेस त्या प्रोग्राम मध्ये ह्यांचा वापर कसा केला जातो, कसं ह्यांना कॉन्फिगर करावं लागतं, सो दॅट वी विल कम टू नो. सिरियल कम्युनिकेशन मध्ये वापरतात. दॅट ओनली राईट नाव यू जस्ट रिमेंबर. देन ऑल द पिन्स दे हॅव कंबाइंड हिअर, दॅट इज 19, 20, 21, 22, त्यानंतर 27, 28, 29, 30. So all these pins belongs to port D. Port D 3 भागामध्ये का 2 भागामध्ये, 2 भागामध्ये डिवाइड झालेला आहे. तर तो इथे त्यांनी नाही 3 भागामध्ये, इकडे लेफ्ट, राईट अँड अबव. ह्या सगळ्या पिन्स ह्या पोर्ट डी ला बिलॉंग करतात, विच अगेन इट इज अ बायडायरेक्शनल इनपुट आउटपुट पोर्ट. When the microprocessor bus is to be interfaced, it can also be act as a parallel slave port. Parallel slave port, that is PSP. PSP ऑब्लिक पिन आउट पशी लिहिलेलं आहे, तर PSP स्टँड्स फॉर द पॅरलल स्लेव्ह पोर्ट. मग where it is used this concept slave master, so that we will see in coming session. So let us move next one, that is the remaining pins in between, that is 23, 24, 25, 26. तर 23 ला काय लिहिलेलं आहे, RC4 SDI आणि SDA. So what is it stands? So it is a can be used. RC4 म्हणजे तर समजलं की port C fourth pin. So what is this? S means serial. So SDI and SDA. So SDA, that is serial data. Serial data. And SDI, that is SPI data in. SPI data in. Got it? इथं दोन मॉड्यूल्स आता नवीन इंट्रोड्यूस झालेले आहेत. SPI आणि I2C we have seen. So and CCP तिसरं मॉड्यूल. तर हे नवीन मॉड्यूल्स आहेत. हे काय आहेत तर त्याच्यावर सेपरेट एक एक सेशन्स वी आर गोइंग टू कंडक्ट फॉर द डिक्लेरेशन ऑर द इंट्रोडक्शन ऑफ ऑल दिस मॉड्यूल्स. तर त्यांना डेटा इन डेटा आउट पिन लागतात. तर त्या कशा कुठल्या आहेत तर पिन नंबर 24, 25, so 23 and 24. So they are used for that the SPI or the this IIC module. Pin number 24, that is the RC5 oblique SD0. म्हणजे port C fifth number pin, or it can be used as a data out for SPI module. SPI module. So this SPI stands for serial peripheral interface. Serial peripheral interface. ज्यावेळेस आपण सिरियली कम्युनिकेशन करणार आहोत किंवा एखाद्या डिव्हाइसला इंटरकनेक्ट करणार आहोत तर त्यावेळेस ही पिन लागणार. सो मॅक्झिमम मेजर ऍप्लिकेशन्स इज द this serial communication for PIC. So we will see that one. Then pin number 25, RC6 TX-CK. So RC6 means port C 6 pin. Then TX and CK, that is it can be used as a USART asynchronous transmit pin. TX that is transmit pin, or synchronous clock. CK stands for the clock. Synchronous clock. तर ही पिन क्लॉक म्हणूनही वापरली जाऊ शकते. Then move towards the next pin, that is pin number 26, RC7 oblique RS oblique DT. Similar to pin number 25. Port C is 7th pin, that is last pin. It can be used as a USRT receiver pin. Serial communication मध्ये ट्रान्समिशन आणि रिसिव्हर असतं, तर ह्या दोन पिन्स कॉन्झिक्युटिव्हली वापरल्या जातात. And DT, that is the synchronous data pin. जर सिंक्रोनसली डेटा पाठवायचा असेल किंवा कम्युनिकेट करायचं असेल तर ही पिन वापरली जाऊ शकते. The remaining, that is pin 33 to 40. So all these belongs to, I think 33. So all this belongs to port B. 8 पिन आहेत, तर पोर्ट बी ला त्या बिलॉंग करतात. सो ऑल आर दे विथ दॅट द बायडायरेक्शनल इनपुट आउटपुट पिन. प्लस ॲडिशनली पिन नंबर 33, जर पिन आउट डायग्राम तुमच्या समोर असेल तर इट इज रिटन RB0 oblique INT. म्हणजे काय, RB0 can be used as an external interrupt pin. INT stands for the interrupt. तर एक्सटर्नल इंटरप्ट पिन म्हणून सुद्धा RB0 ही एकच पिन वापरली जाऊ शकते या पोर्ट बी मधल्या 8 पिन मधली. प्लस RB6 आणि RB7 ह्याच्या सगळ्यात म्हणजे 39 नंबर पिन आणि 40 नंबर पिन. सो दे आर ऑल्सो युज्ड ॲज अ डिबगर पिन. दॅट इज इन सर्किट डिबगर पिन म्हणून सुद्धा ते वापरले जाऊ शकतात. तर हे डिबगिंग मीन्स टू फाइंड आउट द फॉल्ट. Ki if you will not get the appropriate output or as per the expected output, so that time what is the wrong in that the internal hardware or the any coding problem. So that type of the debugging can be possible with these two pins. So how it will be there? So if any program is there in the syllabus, so definitely we will go, but at least you should know about these pins की debugging साठी ह्या दोन पिन वापरले जातात, पिन नंबर 39 आणि 40. So this is all the description today we have gone through for this particular PIC 16F877A. तर as we have seen yesterday, that is the 877. This is the series. ह्या पिक मायक्रोकंट्रोलरची सिरीज आहे आणि हे त्याचं ॲडव्हान्स्ड व्हर्जन दॅट इज ए वी हॅव started to learn. So I hope all of you has noted this all the pin description. Then we'll go for the next slide, which is showing the exact how this advancement came into the existence and what is the actual technical difference between the different series. So just observe this table carefully. So column headings, if you are able to see the cursor, PIC 16F 873, 874, 876 आणि 877. So this series we are learning right now, that is PIC 16 last column, and as compared to the others, so it is a advanced one. So what the comparison points they have taken, you just go through it. We don't have to give the or write this answer in the exam, but we should know as a knowledge of that की ह्याच्याबरोबर कुठल्या कुठल्या सिरीज होत्या आणि त्यांच्यामध्ये काय नव्हतं आणि ह्याच्यामध्ये काय ॲडिशनल आहे. सो इफ यू आर कम्पेअरिंग, दॅट इज द ऑपरेटिंग फ्रिक्वेन्सी सगळ्यांच्या 20 मेगाहर्ट्झच आहेत. देन रिसेट सगळ्यांचे सेमच आहे. देन फ्लॅश मेमरी तर इथं वाढलेली आहे 8 KB. फ्लॅश मेमरी इथं दिलेली आहे 877 मध्ये. डेटा मेमरी पण वाढवलेली आहे 192 वरनं 368 केलेली आहे. EEPROM डेटा मेमरी सुद्धा वाढवलेली आहे, डबल केलेली आहे 128 to 256 बाइट्स. ते महत्वाचं आहे. Interrupts. So here as it is mentioned, that is total 14 interrupts. I hope that it was 13, but it is 14 interrupts are there. And which are they, these interrupts? So that also we will learn. IO ports. कुठल्या कुठल्या series मध्ये 3च ports आहेत, पण 877 मध्ये 5 ports are there. Timer, in all series 3 timers are there. Then CCP module, प्रत्येक ह्याच्यात 2 CCP module आहेत. सिरियल कम्युनिकेशन साठी सेमच मॉड्यूल्स आहेत आणि पॅरलल कम्युनिकेशन इट इज पॉसिबल, दॅट इज PSP with this particular 877 series, parallel communication. So that is, we can say that it is a additional feature. Then ADC, so it is having the 8 input channels. 8 input channels म्हणजे 8 एनालॉग इनपुट्स आहेत. 8 एनालॉग इनपुट्स म्हणजे 8 टाईपचे डिव्हाइस किंवा सेन्सर आपण ह्या 8 पिनला कनेक्ट करू शकतो. टेम्परेचर सेन्सर, प्रेशर सेन्सर, फ्लो सेन्सर, RFID सेन्सर, all other sensor we can just put here UV sensor to these 8 channels. and you will get the digital data. You will get the digital data. And afterwards, the instruction set, which is having only the 35 instructions, but they're working, they're functioning, their syntax. For that also, we're supposed to give dedicated 1 or 2 sessions for instructions. And then we can see the few of the programs for this peripheral interface or the connections. Okay, so I hope this is the what the features tomorrow we will see. Up to here, you just read it today if you will get some time, or note it down in your words, that is on a as like that of our triple P. So that will be better for you to remember or to give the answers for the tomorrow's session. Okay, so based on that, I will just create a little quiz type of this one. So I hope today we will stop here. This is what we have gone through the pin description and the comparison with the other series. And tomorrow we will go with that the features and the next point. Okay, so I will stop here to sharing, and you can just put your attendance in the chat box. Don't forget to put your attendance and you can leave. Automate this live.
Hello, sir.
Yes, who is there?
Kaushik Karni.
Okay, काय आलं कौशिक?
A49 मेसेज नाही आहे सर.
होय का? ठीक आहे मी लावतो अटेंडन्स. का बरं असं होतं काय माहित. Okay, let us see. So anyone else is having problem, you just tell, or you can tell me.
सर A4
Yes. I got. I will put your attendance. A49 Kaushik.
ओके.
Chipra has joined. Chipra madam, are you there? So how you feel now? Are you okay?
Yes, I'm good.
Okay, very good. Thank you.
Thank you.
Roll number 48, Shivraj, are you there? Sanket, are you there? Shweta, Vidya, Vidya madam,
Yes, sir.
have you given attendance?
सर चॅट बॉक्स मध्ये दिसतंय ठेवलं नाही.
Okay, I will put your attendance. You can leave, madam.